Hello everyone, welcome back to another video. So today we'll discuss solutions for bi-weekly contest 134, and I solved all four problems in around 26 minutes. So I think I would have a pretty decent rank. This is not final. I think this will be updated, but I'm pretty sure I will have a under 200 rank. But let's wait for the updation. So we'll start discussing the problems. So first problem. Now in this question we are given a array of integers which is called as colors, and color ith in element in the array represents a tile, uh, a, the color of tile. So if colors of I is 0, that means ith tile is red, and if it is 1, ith tile is blue. Now we have to find a circle. The array, the tiles forms a circle, and we have to find number of 3 contiguous tiles such that it is alternative. Means all 3 colors are alternative, so their configuration combinations of that configuration are red blue red or blue red blue, and we have to basically return how many such 3 contiguous tiles are there such that they form alternating colors. Now this is a circle, so it is important to understand that last tile will form or can also form a group with first and second tile. So that is also you should consider while printing the answer. So let's start with the example. So let's say this is the colors array, all of them are blue. Now each alternating group can be uniquely identified by the starting index. So if I start from index I, the contiguous tiles will be present at I plus 1 and I plus 2, but when I is itself n minus 2 or n minus 1, so the I plus 2 value will exceed n, so we have to take the mod. So how to represent 3 continuous tiles? It would be I mod n, then I plus 1 mod n, and the third tile I will represent as I plus 2 mod n. Now why I did this? Because let's say I is n minus 1, then I plus 1 means its right tile means its next tile should be 1. So if I put I as n minus 1, my answer would be n mod n, so basically 0. So n minus 1's next tile is 0, similarly next tile will be 1. So it will consider those cases where the tiles might exceed n, or basically the circle gets completed. So this is the representation of 3 tiles. Now it's just simple implementation problem. So first of all, I am declaring an n, which is size of array, declaring a counter. Now I'm iterating over 0 to n, then I'm checking if these tiles are alternating. So third tile is not equal to second tile, and second tile is not equal to first tile. That's enough to check if they are alternative or not. And finally I will, if the condition is met, I will increment counter and return the counter. So this was first question, pretty easy. The third question is interesting. It's second part of this question, where the only change is that contiguous, here the contiguous tiles have size 3. In third question we are given k, and k is dynamic, that means k is given as input. We will discuss it further, but first we will discuss the second problem. So we are given enemy energies, which is a array of energies of enemies, and also given a current energy, which is denoting the amount of energy we have initially. And we are starting with 0 points and all the enemies are unmarked initially. So we can perform one of the operations 0 or multiple times to gain points. So first operation is, one of the type of operation is choosing an unmarked enemy I such that current energy is greater than equal to enemy energy, and by choosing this option we gain 1 point, and current energy also is deduced by that energy of that unmarked enemy. And if we have at least 1 point, we can perform second type of operation, which is choose an unmarked enemy, and by choosing it we mark it, and the current energy increases by that enemy's energy. So let's take an example. 322 and current energy is 2. So first of all, at first step the current energy is at first step we cannot perform second type of operation because we don't have at least 1 point, because we are starting with 0 points. So in first step we always need to perform first type of operation. So for this two I can choose this two, and what I will do is I choose this unmarked index and gained 0.2, and current energy becomes 0. So array remains as it is, and in first type of operation we are not marking the element index, we keep it as simple. So it is 0 0 0 0 means unmarked, and if I make them 1 it will be marked. So now I have 1.0 current energy. Now what I can do is I can mark one of the elements and gain that energy. So which element I can mark? This element I can mark. This I can remain as it is. So energy gained is 3, point is 1 itself. Now again I can unmark this 2. I can mark this 2 and gain its energy. So 3 2 2 and 2. So 1 1 0. Now I have 5 points, 1 energy point. Now there is no use of marking this 2. Even if we have after marking our energy increases, but there are no unmarked enemies which can be used to increase our points. So now using 5 I will increase my energy by performing two operations on second index. So first it will become 3, energy will become 2, then it will become 1, and energy will become 3. So there was some kind of pattern which was optimal to gain maximum number of points. Now let's say first observation, let's say we have energy E, and let's say array of energies is called as E, and C is current energy. What is the maximum number of points you can gain using this C? So it would be C by minimum of E, because decreasing the current energy with minimum, let's say I have energy 5 and I have two options. Either I can decrease the energy with 1, decrease the energy with 4, and gain same number of points with both the performing operations on any of them. So even if I perform operation on this index I will gain 1 point, even if I perform operation on this index I will gain 1 point. But performing on this index is optimal because the remaining energy is high, means the energy which is used to perform on this index is low. So lesser the energy required for performing one operation, more is the number of points you will gain. So it is always optimal to use the energy on minimum element of energies array. Now the second type of operation, now if we are only using minimum E, and which will remain unmarked till last operation, we can always mark all the other elements. So first to n, let's say E is sorted now. So we will sort it when before solving the problem. Now minimum of E would be E of 0. So E of 0 will remain unmarked, and all the other elements I will mark them. And this sum would be this, all the energy will be gained by and current energy will increase by sum of 1 to n minus 1. So this is the optimal way to do it. So first of all, add all the energies from 1 to n minus 1 to C after sorting the array, and C by E of 0 would be the answer. Now there is also one edge case that we can add this energies into my current energy if and only if I have a single point. Now how to gain a single point? It would be C minus E of 0, means performing one type of operation first. Now this should be the condition for it, because if let's say I have current energy 2 but the minimum energy required to beat an enemy is 5, I cannot gain a single point even if there are 5 and 10 which can be added here. But to add it to my current energy, I should have at least 1 point, and there is no way to gain 1 point. So for this case answer would be 0, and for all other cases it would be C plus sum of 1 to n minus 1 divided by E of 0. So let's see the code directly. So first of all I will sort the array, and if A of 0 is greater than D, that means I cannot gain a single point, so I will just return 0. And if that condition is matched, that means I have gained 1 point. Now I can take all the energies from 1 to n then, and final number of points would be sum by A of 0. So this was the second question. So now the third question is same as first, only the difference is we have to find k contiguous tiles. Alternating group is where every k contiguous tiles are alternating. So in first question k was equal to 3, but here k can be anything from 1 to n. K can be anything from 3 to n. So first case, let's say 0 1 0 1 0 and k is 3. So alternating groups can be 0 1 2 index, 1 2 3 index, and 2 3 4 index. Similarly, if this is the array and k is 6, the first alternating group would be 3 4 5 6 and 0 1. So all these are alternate. Similarly 4 5 6 0 1 2 is also alternate. Now if after reading this question, first thing which will come to your mind would be sliding window. So first I will process all the elements from 0 to k minus 1, then I will move the window to 1 to k, then through 2 to k. Now how to maintain the information while going from 0 to k minus 1 to 1 to k? Now you can do that by just, so let's say 0 to k is something like this, an alternative, it is an alternative group. Now while moving it, you need to compare this, that means the next element of start of previous sliding window and the next element which is end of previous sliding window. You have to consider that. But the problem in this type of approach would be considering when the array itself is not alternating. So what type of information are you taking to your next sliding window, next window? So I found this implementation a little bit tricky. So I used a different approach. Now what was my approach? Let's say I have an array of size 5. Let's say k is 5. Now what type of information I would store for this array such that I can understand that this subarray is alternating group. So for that, what I can do is, first of all, start of array would be 1 or x itself, x or 1. Let's consider it as 1 for now. Now whenever I am transitioning from 0 to 1 or 1 to 0, that means adjacent elements are not equal, I will add 1. So 1 to from this index, the value here would be 2. Similarly, here would be 3, here would be 4, and here would be 5. Now if this alternating group, this array is alternating group, then this value minus this value means 5 minus 1 should be equal to k minus 1. Now why is that? Because there are basically k minus gaps in an array which has length k. This one, this one, this one, this one. Now if all adjacent elements are unequal, whenever there is an adjacent element unequal, I am adding +1 to the value which we are storing. Now if the value itself is equal to k minus 1, means all the gaps have adjacent elements unequal. So via this type of representation, representation, we can find if a array from I to I plus k is a alternating group or not. So another example would be, let's say this. So let's say value here was 1. Now moving to its right, value will remain same. Moving to its here would be 2, and here would be 3. Now this cannot be an alternating subarray because 0 0 are adjacent are same. And we can also find that using this trick where 3 minus 1, not trick, I would say it is just prefix sum. So 3 minus 1 is not equal to 3, means k minus 1. K here was 4. So we can say that this is not an alternating group. But this which is starting from this 0 and this ending at this 0, the difference is 2 and the array length is 3. So 3 minus 1. So both the values matches, and we can say that this subarray is alternating group. So now what we have to do is start from 0, check 0 to k is 0 to k minus 1 is an alternating group or not by just maintaining a prefix sum. You can do it in of 1. So p of k minus 1 minus p of 0 should be equal to k minus 1. Similarly for 1 to I have to check to k. Now the only problem is when we have to check for circular. So from index, let's say n minus 1, I have to check k elements. So this is one element, and then next k minus 1 elements from 0 to k minus 2. So this is type of circular representation. How to check for that? So to check for that, first of all, we'll check if this is alternating, then we will check if this is alternating, and if both of them are alternating, I will also check if these two elements are alternating or not, means start of that end of this array and start of this array. Now these three conditions are enough to check this. You can try run this, you will understand why it works. So let's see the code. This is also an easy question, I would say, not so difficult. So first of all, declaring prefix sum, and pf of 0 is 1. Now for each index from 1 to n. If a of I is not equal to a of I minus 1, then I will increment p of I and just take prefix sum. So p of I must be added with prefix sum of I minus 1. Now answer is the variable to store the count. Then I'm iterating over 0 to n. So 0 to n, I is just the start of the subarray. Now if I plus k minus 1 is less than n, that means end of my subarray is less than n. That means it is not forming any circular subarray. I will take its difference as p of I plus k minus 1 minus p of I. If it is k minus 1, I will increment the answer. Now the second condition where there is a circular subarray formation. First of all, I will find the difference of first subarray. Then I will find the difference of second subarray. Now this difference should be k minus 2 and that additional case. So here we are comparing k minus 1. Here it is k minus 2 because there is a break. Now that break I have checked separately, which is a of 0 not equal to a of n minus 1. And if these conditions are met, I am incrementing the answer. So this was the third question. Now fourth question is, I'm pretty sure this is a repeated question. I don't know. I think this question has arrived a lot of times. At least the concept is arrived. Concept is asked a lot of times. So it is important to learn this concept, I would say. So what we are given is, we are given an array nums and an integer k. So we have to return number of subarrays such that the bitwise AND of the elements in that subarray is equal to k. So let's start with this first sample test case 1 1 1. So 1 1 1. So first of all, subarrays with size 1 would be 3. Subarrays with size 2, there are two subarrays, and subarrays with size 3, there is single subarray. So if you take AND of all the subarrays, you will get AND as 1 itself. So this also has 1, this also has 1, this also has 1. 1 and 1 is 1, also 1, 1 and 1 is also 1, and 3 times taking AND of 1 is also 1. So here all the subarrays have bitwise AND equal to 1. So the answer is total number of subarrays, that is 6. Similarly, in this case, there are only 3 subarrays which can form bitwise AND equal to k, and these are the examples. Now this requires the solution which I wrote requires segmentary, but I think there would be an easier solution, but I couldn't. First solution which came to my mind was of segmentary. So first of all, we'll start with observations which are important. So the first observation is not an actual observation, it is the property of AND. So let's say I have an element a1, and if I take its AND with a2, let's say C is the result of this. Now C would always be less than equal to a1. Means taking an AND of current integer to another integer would always result in its the resultant AND would be always less than equal to any of the element. So the continuous AND, taking continuous AND as a1 a2 a3, this type of function is monotonically decreasing. This is monotonic, means it is decreasing. Means if I take AND, let's say I am taking AND with from A1 to A3, and I am taking AND from A1 to A5. So this A1 to A5 AND will always be less than equal to A1 to A3 AND. So I just explained an example of what this monotonicity uh, states. So how this how this property is helpful? Now let's say I'm starting from this array I, starting from an index I. Now let's say the first index which is giving me the array and as j, and of that subarray is k. So what I can say is I to j and gives me value equal to k. Let's call it j1. Now all the elements before j1, that means I minus I2, let's say j1 minus 1, would give and greater than k. So this is the first element which gives me and as k. Now this is I hope you understand this. So this is the first element which gives and equal to k. So its previous element will always give greater than k because it is strictly decreasing. Not strictly, but it is decreasing. Now let's say j2 is the last element which gives me and as k. Now here also you need to understand that if I take and from I to j2 plus 1, it would be less than k, because this is, we have considered j2 is giving the last and equal to k. Now if I start the subarray from I, what is the count of subarrays which will form and as k, which are starting from I? It would be j2 minus j1 plus 1. So first subarray is I2 j1, the second I2 j1 plus 1, I2 j2 j1 plus 2, and up to I2 j2. So that count of subarrays would be j2 minus j1 plus 1. Now how can we find these values of j1 j2? So you can find them using binary search. Let's say there is a function which gives me a and of n subarray in of log n or of 1 reasonable time complexity. Now I can write binary search on end point of this whole array. So from I to n minus 1, and this is, as this is in monotonic, in first binary search I will find j1, in second binary search I will find j2. This is just similar to finding lower bound and upper bound. So writing that binary search would not be difficult. Only how this function can be implemented. So this function can be replaced with segment tree. So segment tree basically finding the bitwise and often range. So overall solution looks like this. First of all, build a segment tree. Then for each I iterate for over 0 to n, where I represents start of the subarray, and then find these two indices j1 j2 if they are present. Means there might be not even single index j1 j2 which is equal to k. So additional condition is also important. In binary search you will find the first element which is greater than equal to k, and last element which is greater than equal to k, first element which is less than equal to k. So you binary running binary search and then considering the case where there is no single subarray which is exactly equal to k. So you have to understand, you have to handle that case also. So binary search plus segment tree plus binary search from I to n, and we are iterating from I. So overall solution will look like, complexity would look like O of log square n, binary search iterating over I from 0 to n, and log n for binary search and another log n for queries. So first of all, how I would tell you, if you don't know segment tree, where you can learn it. So there is a playlist of Vivek Gupta. So he has explained uh, all the segment tree and lazy propagation with some examples, and this is the same template. This is probably the simplest template which you can find on binary search, because in his video he has explained it how it works, so you can also use it and build it for yourself. So you can watch the video. This is the same template which he explained, so you can find it on my GitHub. So watch the video, understand segment tree, and don't just understand it for using that template. Understand it thoroughly, means how lazy propagation works, how segment tree works. So you can watch that video, and also you need to understand how binary search works. That is just simple lower bound and upper bound code. So first of all, building the binary segment tree. This is the template. Then I have declared an answer variable. I am iterating from 0 to n. Now I have declared two variables, left and right. Actually, left is the rightmost. Left is j2 and right is j1. So for I named them differently, but you can understand them by this binary search. So first binary search for finding the rightmost element, which has for finding j2, and then next binary search for finding j1. Now this is an upper bound lower bound type of code. So if you don't know binary search, I will prefer I will suggest learn it. It is one of the most important topic. And after the binary search, if left is not equal to -1, that means I don't find any element. So in that case, left would be -1. So I handled that case, and then if there is at least one element which has exactly equal to k, it will be stored in right or left. So it would be stored in right, means it would be stored in both of them. So I'm just checking the value if it is equal to k. If it is not equal to k, that means there is no single subarray, and I'm just adding left minus right plus 1. So j2 minus j1 plus 1. This was the fourth question. This is very repetitive question, I would say. I think the same question, everything same as this problem statement has been asked previously on Leetcode itself, but I'm not sure. At least the concept is very repetitive. So I think that's it from my side. I have a good rank. So according to this, it is 89. But it shouldn't be 89. If you see the rank 51, it has 27-minute penalty. I have 26. So I don't know, it's still not updated. But yeah, that's it from my side, and thank you for watching.